This is mathheals.com. You can come here to get more math videos, YouTube that is. Let's take a look at models involving rational equations. And let's take a look at our first one. So let me get my pen to work. There we go. X plus 9 over 4 equals x minus 4 over 7. Now specifically, this is a proportion. Proportion is when you got a single fraction equal to a single fraction. So a single fraction equal to a single fraction. That's what the form looks like. Here we got a single fraction equal to a single fraction. If you do that, to solve a proportion, what you can do is you can do something called cross multiplying. So I'm going to take 4 times x minus 4, and we'll take 7 times x plus 9. So we got 4 times x minus 4, and 7 times x plus 9. Well, we got, and this only works when you got a single fraction equal to a single fraction. If I had a plus 2 over here, it wouldn't work. So we got 4 times x, which is 4x. 4 times negative 4, which is negative 16. 7 times x, which is 7x. And 7 times 9, which is 63. Now I get all the x's on one side, numbers on the other side. So I take 7x to the left side, becomes a negative 7x. Take the negative 16 to the right side and becomes a positive 16. Well, combine together like terms. 4x minus 7x is negative 3x. And adding these together I get 79, looks like. Last step, divide both sides by a number in front of your x. And we get x is equal to negative 79 over 3. Now we would normally check this to make sure it doesn't cause a 0 in the denominator. You should do that anytime you have a rational equation, but there's no x's in the denominator, so there's no way we can get a 0 there. So that'd be your answer. Let's take a look at another one of these. We got x plus 2 over 5x minus 12 equals 3 over x. Now we got a single fraction equal to a single fraction, so again we'll cross multiply. Take x times x plus 2 and 3 times 5x minus 12. So we got x times x plus 2 equals 3 times 5x minus 12. Well, x times x is x squared. X times 2 is 2x. 3 times 5x is 15x. And 3 times negative 12 is negative 36. Now to solve this one, we have an x squared. So we want to get everything over one side and 0 on the other. So I'm going to take the 15x minus 36 to the left side. And we got x squared plus 2x. The 15x becomes a negative 15x, and negative 36 becomes a positive 36. Combine together like terms. 2x minus 15x is negative 13x plus 36 equals 0. And this factors using the PSD method. It factors as x minus 9 times x minus 4 equals 0. Zero factor property. You get 0 on one side, you factor the other side, set each factor equal to 0. So I'll set x minus 9 equal to 0 and x minus 4 equal to 0. And we get 9 and we get 4. Now we want to make sure these don't cause a 0 in any of our denominators. If I put 9 back there, 5 times 9 is 45 minus 12, that's not 0. If I put 9 here, that's not 0. If I put 4 here, 5 times 4 is 20 minus 12, that's not 0. If I put 4 here, it's not 0. We don't care what it actually equals, we just want to make sure it doesn't give us 0. Now you could go through and fully check it, but if you feel good about all your steps, that's the only thing you have to go through and check. Okay, now let's look at similar triangles. Actually, it'll be similar geometric shapes here in a minute, but okay, so we got A, B, and C. And I'm not going to draw this real well, but you'll get the idea. And then we got another triangle that's D, E, F. D, E, and F. And they tell us triangle ABC is similar to triangle DEF. Now similar, and I kind of drew it kind of halfway decent there, means that this angle is the same as this angle. This angle up here is the same as this angle. And then this angle here is the same as this angle in terms of degrees. Well, these sides will be different sides, but they'll be proportional. So if I compare this side to this side and then set it equal to like this side to this side, they'll be proportionally equal. And we're going to use that to help us figure out what they're wanting. Okay, it says DE is equal to 10. So this side is 10. EF is 8. Use your imagination. I know it looks longer. AB is equal to 30. That's 30 and this is 10. Again, use your imagination on this. Find BC. So we're trying to find this. Now, I was lucky to get numbers that actually worked out halfway decent on most of these. These are just numbers right here, so it wasn't too hard. Now we're trying to find out what this value is. So that's like our variable. That's x. There's different ways you can set up these proportions. So I can do this side to this side. So I can do x over 30 equals, and now I went from this side to this side, so I have to go from this side to this side. So this would be 8 over 10. You could also have done this side to this side. So x over 8 is equal to, and then this side to this side. So you'd have 30 over 10. You'll find you'll get the same answer either way, how you set it up. Well, this is a proportion, so I'm going to cross multiply. I'll take 10 times x and 8 times 30. So 10 times x is 10x, and 8 times 30 is 240. Divide both sides by 10. And we're going to get x is equal to 24. So this side here would be 24 in length. And let's look at another one. ABC and DEF. Okay, if AB is equal to n, so this AB here, this distance is n. BC is equal to n plus 3. So BC is n plus 3. DE is equal to 7. And EF is equal to 10. It says find n and then find BC. Okay, so first off, we can set this up. So this would be n over n plus 3 equals 7 over 10. And probably the easiest way to find n is just go ahead and solve this. So this is a proportion, a single fraction equal to a single fraction. So we'll cross multiply. So I'll take n times 10, which is 10n, equals 7 times n plus 3. Well, 7 times n is 7n. 7 times 3 is 21. Get everything with an n on one side and numbers on the other. So I'll take 7n to the left side, and becomes a negative 7n. Combine together like terms. 10n minus 7n is 3n. Divide both sides by 3. And we get n is equal to 7. That's the first thing they're asking for. Find n. And then it says find BC. Well, BC is right here. It's n plus 3. And we just found out what n is. So we got 7 plus 3. BC is equal to 10. And this is our n. Let me start a new page. And let's look at the next one. It says rectangular ABCD is similar to rectangle EFGH. So ABCD. ABCD. And this one is EFGH. Okay, let's see what they give us. If DC is equal to 10, so DC here is 10. FG is equal to x minus 3. FG is equal to x minus 3. DB is equal to 4. DB is equal to 4. And GH is equal to 5x minus 40. GH is 5x minus 40. It says find x and HE. So we're finding HE. Let's first find x. So we can set this up as a proportion. So I do 4 over 10 is equal to x minus 3 over 5x minus 40. Now again, we're dealing with a proportion, so we can cross multiply. So multiply 10 times the x minus 3 and 4 times 5x minus 40. So I got 10 times x minus 3 equals 4 times 5x minus 40. 10 times x is 10x. 10 times negative 3 is negative 30. 4 times 5x is 20x. 4 times negative 40 is negative 160. Get everything with x on one side, numbers on the other. So take 20x over, becomes a negative 20x. Take the negative 30 over, becomes a positive 30. Combine together like terms. 10x minus 20x is negative 10x. Negative 160 plus 30 is negative 130. Divide both sides by negative 10. And we get x is equal to 13. That's the first thing they're asking for. Next thing they're asking for is HE. So they're wondering what this side is here. Well, this is a rectangle, so HE is the same as FG. So HE is equal to x minus 3. It's the same as this side. And x we just said was 13. So we got 13 minus 3, which gives us 10. Now, here's a shared work problem. And let's talk a little bit about that. It says write an equation that can be used to model each of the following. Set up but do not solve the equation. Now, shared work goes like this. You put 1 over the time it took person A plus 1 over the time it took person B equals 1 over the time it took together. So that's your setup. So it says David can paint a fence in 10 hours. He is slow. And Frank can paint the fence in 6 hours. How many hours will it take to paint the fence when David and Frank work together? Okay, so we got David first. David can paint it in 10 hours. So David would be 1 over 10. Frank can paint it in 6 hours. So for Frank, it'd be 1 over 6. Equals 1 over time it took together. And that's what they're asking. How many hours will it take to paint the fence when David and Frank work together? So they're asking 1 over x. And that'd be our equation. And they're just wanting us to set it up. They don't want us to actually solve it. Number 8, or 7, sorry. You got a right equation that can be used to model each of the following. Set up but do not solve the equation. Sally can paint a fence in 8 hours. When she worked with Judy, it took only 3 hours. How long would it take Judy to paint the fence if she worked alone? So we got Sally. We got Judy. And we got together. So we read it again. Sally can paint a fence in 8 hours. So this would be 1 over 8. When she worked with Judy, so they're working together, it took only 3 hours. So this would be 1 over 3. How long would it take Judy to paint the fence if she worked alone? So this would be 1 over x. And it wants us to set it up, not to actually solve it. Okay, another shared work. This says write an equation that could be used to model each of the following. Set up but do not solve the equation. There are two different inlet pipes that can be used to fill a 2,000-gallon tank. Pipe A takes 8 hours longer than Pipe B to fill a tank. With both pipes open, it takes 20 hours to fill a tank. How long would it take Pipe B alone to fill a tank? Okay. So we've got Pipe A. We've got a Pipe B. And I didn't mean to put equals there. And we got together. Okay. I noticed it right here. It says takes 20 hours to fill the tank when both of them are open. So together, it's 1 over 20. Now Pipe A takes 8 hours longer than Pipe B. And it says how long will it take Pipe B alone to fill the tank. So we don't know Pipe B. So that's our x. So we'll have 1 over x. Now Pipe A, it says it takes 8 hours longer than Pipe B. Well, if Pipe B is x, and this takes 8 hours longer, this will be x plus 8. And that'll be our setup. Let me start a new page. Of course, if we wanted to work it, we could solve those with what we know about rational equations now. Okay, let's look at this one. It says, write an equation that could be used to model each of the following. Set up but do not solve the equation. This is where you're talking about something moving in water, and it's either going upstream or downstream. Now our equation goes like this. The distance upstream over the rate in still water minus current speed is equal to the distance downstream over the rate in still water plus current speed. Now we'll represent current speed as c, I guess. And let's see what we're given. David's boat travels at 10 miles per hour in still water. Find the speed of the current, so find c, if you can go 2 miles upstream in the same time it takes to go 5 miles downstream. So the first one is 2 miles upstream. Okay, so let's come over here. Our formula says distance upstream. 2 miles upstream. So that'd be 2. And travels at 10 miles per hour in still water. And going upstream. Well, if you're going upstream, you're working against the current, which means you're going to have 10 minus c. Now 10 is in still water, so that's your speed in still water. And when you're going upstream, you're working against the water, which means your speed's going to be slower. So that's why it's a minus c. Now over on this other side, distance downstream, we said 5 miles downstream. So put 5 here. And we're still going 10 miles per hour in still water. So we're going downstream, so the current's with us. So it's pushing us along faster. So this one will be 10 plus c. And of course this is a proportion, so you could solve this if you wanted to. I made the numbers up, so they probably don't come out, they probably come out weird. But okay, last one. Write an equation that can be used to model each of the following. Same setup. Okay, a stream has a current of 5 miles per hour. Okay, so that's our current speed. Find the speed of David's boat in still water. If he can go 8 miles downstream in the same time as it takes to go 3 miles upstream. Well, distance upstream is still 3, or not still, but it's 3. And 8 miles downstream, so that would be 8. Okay, rate in still water minus the current speed. And they tell us the current speed is 5. So we're trying to find the rate in still water. So let's put a variable there, r, I guess. So r minus current speed. So we got r minus 5. And this is rate in still water plus the current speed. So this will be r plus 5. And I've already explained why does it work that way for upstream and downstream, so I won't do that again. But that would be our equation to set it up, and then we'd work it from there. And I believe that was the last problem. So I'm going to stop the recording and then save it.